Welcome back to The Explainer, everyone. Whether you're a professional breeder, an aquaculture specialist, or just a really dedicated aquarist, you are in the right place. Today, we're digging into a technical guide on a species that basically laid the foundation for modern tropical fish keeping. We're talking about the paradise fish, or Macropodus opercularis. We've got a lot to cover, from the hard science to the incredibly strict husbandry and specialized care this little micropredator actually demands. So let's just jump right in. Here's our technical blueprint for today. We'll start with an introduction and some evolutionary biology, move into parameters and their subtropical habitat, then tackle behavior and optimal nutrition. After that, we'll break down the technical breeding dynamics, and finally, wrap up with pathologies and health management. All right, Part 1, Introduction and Evolutionary Biology. So fun fact, this species was actually the first exotic fish successfully bred in captivity way back in Paris in 1869. And a huge reason for that success is an absolute evolutionary marvel they possess called the labyrinth organ. Like all annabintoids, they have this highly vascularized superbranchial structure, which, evolutionarily speaking, is derived from the first gill arch. But why does that matter to us? Well, it acts as a vital oxygen regulator. It literally lets the paradise fish process atmospheric oxygen. So while other fish might panic or just shut down their vital processes in severely hypoxic, oxygen-depleted waters, this fish behaviorally compensates. It maintains a totally normal aerobic metabolism just by gulping air from the surface. It's how they survive in stagnant, muddy paddy fields out in the wild. And to really grasp just how seriously the scientific community takes this fish today, just think about this number: 483 megabases. That is the exact size of its recently sequenced de novo whole genome assembly, which researchers just mapped out in 2024. Having this rigorous scientific baseline proves that we aren't just dealing with an ornamental pet here. It is a deeply complex biological model, and it's got this incredible adaptive resilience coded literally right into its DNA. Moving on to Part 2, Parameters and Subtropical Habitat. Okay, I want you to consider this temperature for a second. 0 degrees Celsius. That is a truly shocking minimum temperature tolerance, right? And it highlights a really crucial fact that a lot of people miss. The paradise fish is a highly adaptable subtropical species. It is not strictly tropical. These guys have literally been recorded actively swimming under layers of ice in outdoor ponds. So if you're keeping them perennially at standard tropical temperatures, you're actually doing them a huge disservice. It accelerates their metabolism, dials up their aggression, and significantly shortens their lifespan. So what does that mean for your specific setup? Well, for optimal water parameters, you want to aim for a temperature range between 10 and 22 degrees Celsius. They're pretty flexible with pH, tolerating anywhere from 6.0 to 8.0, with a hardness between 3 and 18 DKH and conductivity hovering right around 350 to 450 microsiemens. Now here's the kicker. Providing a proper winter cooling period within those thermal ranges isn't just a suggestion, it respects their natural biological cycle and actively prevents premature aging. For professional care, it is absolutely non-negotiable. Which brings us to Part 3, Behavior and Optimal Nutrition. Behaviorally, you're going to see a really stark dichotomy with this species. On one hand, you have extreme male territoriality. The males will establish these rigid 30 to 40 centimeter perimeters, and they'll actually engage in jaw-locking combat to test each other's strength. I mean, historically, they were used in fish fighting matches, which is how they got the totally metal nickname, Butcher of Fighters. A solitary male will absolutely decimate slow-moving tank mates, microinvertebrates, honestly anything with filamentous fins. But on the flip side, you have female passivity. And here is a huge professional secret. If you actually want to keep this species in a peaceful community setup, housing an exclusive harem of females is 100% the way to go. They're super tolerant, and you completely bypass all that extreme belligerence you get from the males. Now let's talk food, because aquaculture research shows us there are some pretty strict dietary demands here, depending entirely on your operational goals. Remember, these are micropredators. You can't just throw generic flakes at them and expect great results. If your main goal is somatic growth, maximizing mean weight gain and getting that optimal food conversion ratio, you need a diet hitting exactly 40% crude protein. But if you're gearing up for breeding, you need to bump that up to 45% crude protein. That is the scientifically proven sweet spot to optimize reproductive performance and spawning quality. So yeah, it's really all about doing the nutritional math. All right, let's get into Part 4. Technical breeding dynamics. Let's quickly walk through the operational steps for breeding because they are strict. Step 1, you have to establish a 1-to-1 male to female ratio. Step 2, Keep an eye out for the nuptial embrace, which happens right under a nest made of tiny 1 mm bubbles that the male literally builds using surface-active proteins. Now, step 3 is crucial. You must remove the female immediately after spawning. If you don't, that fiercely protective male is going to see her as a threat and he will attack her. And finally, step 4. You need to seal the tank to trap a humid 26 degrees Celsius air layer right above the water. Guys, I cannot emphasize this enough. Sealing that tank, usually with plastic wrap, is an absolute life or death requirement. Without that trapped warm, humid air, the fry's labyrinth organ just won't develop and you'll be looking at massive die-offs. And finally, part 5, pathologies and health management. I want to shift gears and get a bit serious here to talk about biosecurity, because this resilient fish still faces some severe threats. Now, a lot of their health issues actually stem from immunological stress, usually from tank mate incompatibility or just being kept way too warm. But the absolute most devastating threat is megalocytovirus. The systemic effects of this virus are just brutal. We're talking anorexia, severe hemorrhagic syndrome, and widespread internal organ necrosis. Recent histopathological studies show it even induces splenomegaly, which is a dangerously enlarged spleen, along with severe lymphoid depletion. Basically, this virus just completely shuts down the fish's cellular immune response. Aside from that, there are a few secondary, but still highly lethal, threats you need to monitor. There's lymphocytic disease virus, or LCDV, which shows up as these wart-like nodules on the fins. Then you've got an opportunistic bacterium called Citrobacter foindi, and that one triggers acute hemorrhagic enteritis and massive internal bleeding. Oh, and we definitely can't ignore anabentoid iridivirus either. Because these specific pathogens are just so destructive, consider this your firm reminder of the golden rule of aquaculture. A mandatory 30-day quarantine for literally any new specimen is absolutely essential to protect your established stock, no exceptions. If this technical guide has helped you get a better handle on optimizing your breeding setups, managing those tricky water parameters, or preventing major pathologies, definitely take a second to subscribe to our channel. We do these expert aquaculture breakdowns regularly, and your support is what lets us keep sharing this vital data with the professional community. To wrap up today's explainer, I want to leave you all with something to chew on. When you look at its incredible thermal resilience, literally surviving near freezing temperatures, and that highly evolved air-breathing physiology, what do you think the evolutionary future looks like for this incredibly adaptable survivor in our rapidly changing global climate? It's kind of a wild question for any dedicated researcher or breeder to think about. So keep studying, keep observing, and thanks so much for joining me today to explore the science of the paradise fish. See you next time.